studying.
Here, Leah.
I woke up the other night, my blood just froze. I dreamt I took the SATs without no clothes. Oh, I got SAT blues. I got everything to lose. I got SAT blues. I got everything to. Don't wanna stay up all night reading the dictionary. Words I just don't understand. I opened up the test booklet. I let out a shriek, 'cause half the questions were written in Latin and Greek. Oh, I got SAT blues. We got everything to lose. I got SAT blues. I got everything to. What do I do with these fractions? I can't figure this equation out. The numbers keep spinning round. I don't know a hypotenuse from an isosceles triangle. It turns me upside down. Oh, I got SAT blues. We got everything to lose. I got SAT blues. We got everything to. SAT blues. We got everything to lose. SAT blues. We got everything to.
That's SAT Blues, the new hit single by PTD and the Students. And for all you juniors and seniors out there singing the SAT Blues tonight, don't you worry, because we're going to dedicate this whole show to you.
Good evening, and welcome to the Castle Integer here in the land of odd and even. My name is... But who I am and what I am are not important. What is important here in the castle is you. You and... mathematics. Does that scare you, mathematics? It shouldn't, you know. Math is really quite simple. Especially the kind you use to dig up answers in that dreary thing you mortals do, the scholastic aptitude test. So simple. All you need to do is remember the things you've known for year after dusty year. Addition, subtraction, fractions, percentages, basic earthly arithmetic concepts like that. There's nothing to fear. Sounds too simple, does it? Think you know it all? Well, beware. Overconfidence is like the cobwebs of this castle. They will blind you and deceive you so that you'll stumble into the ghastly clutches of error. Did I frighten you? 1,000 pardons. I only mean to warn you. It is true. You should never fear the math of the SAT, but there are demons lurking in the shadows. Demons that will try to trick you and confuse you and make you abandon what is right. These demons must never be left untamed. But trust me, armed with only the torch of good sense and practice, you shall contain these demons. Hark, the hour grows late. Come, come with me now, and I will show you how to use the simple building blocks of your own knowledge to vanquish these demons lurking in the darkness. Shed a bit of light on these demons, and you can see they are nothing more than numbers, the basic building blocks of arithmetic. You think you know all about numbers, Well, beware. Know all the names they go by. Learn to recognize them instantly before they trick and trap you. An integer is another name for whole number, not a fraction. Anything from 1 to, well, 1 million and beyond. Personally, my favorite integer is 13. There are positive integers and negative integers. Zero is an integer, but it is neither positive nor negative. On the SAT, you may see a number line with 0 in the center. Note that the positive numbers grow bigger as they move right from the 0. Negative numbers grow smaller as they move left from 0. For example, -8 is smaller than -3. Be sure you know the rules for working with signed numbers. When adding numbers with different signs, subtract the smaller number, not counting the sign, from the larger number and use the sign of the larger number. With subtraction, change the sign of the bottom number and add the two numbers following the rules for addition. And remember the rules for multiplying with signed numbers. When the signs are the same, the product will always be positive. When the signs are different, the product will always be negative. For division, when the signs are the same, the quotient is a positive number. When the signs are different, the quotient is a negative number. And never forget the odd and even behavior of numbers. See what happens when you add two even numbers, or two odd numbers, or an even or an odd. See what happens when you multiply in these various combinations. Even numbers can be evenly divided by 2, that is, with no remainder. Odd numbers cannot. You will always have a remainder of 1. You will thus always have a quotient that is a whole number plus the fraction 1/2. Recognize that the longest of even numbers will always end in an even number, and the longest of odd numbers will always end in an odd number. And you should know about consecutive integers and how to express consecutive integers in terms of a variable. Consecutive integers are numbers that follow each other, such as 3, 4, 5, 6, or 45, 46, 47, or 48. If you don't know the first number, you can call it n. Then the series would be expressed as n, n plus 1, n plus 2, n plus 3, and so on. And do you know what prime numbers are? Yes, here they are. Silence. A prime number is any number that cannot be divided by any other number but 1 and itself. These are prime numbers. 2, 3, 5, 7, 13, 17, 19. All integers are made up of digits. There are, of course, 10 of them. For instance, the number 1,234 contains 4 digits. Remember this. The SAT does ask questions that require you to know these things cold. And now, do you recall what you do with these numbers? The basic operations of arithmetic? You add, multiply, subtract, and divide them, of course. Simple, yes? Of course. Until you become careless and make mistakes that cost you valuable points. Mistakes such as these. Failing to remember what the results of the 4 basic operations are called. Addition yields a sum or total. Subtraction yields a difference. Multiplication yields a product. And division yields a quotient. Know these terms. Do not waste time on the test trying to remember when a question calls for the sum of two numbers or the product of two numbers. And now, on to those fractions. Fractious, a word you should note. Peevish, unruly. But don't worry, they can be tamed. Fractions, or I should say proper fractions, are numbers less than 1. The number above the line is called the numerator. The number below the line, the denominator. A fraction can also be expressed in terms of division. The fraction 1/2 also means 1 divided by 2. To add and subtract fractions, they must have the same or common denominator. You simply add up the numerators and place the sum over the common denominator, or subtract the numerators and place the difference over the denominator. If they do not have a common denominator, you must find one. This will be the lowest number that can be evenly divided by each denominator of the numbers you have to add or subtract. To change each fraction, you divide the common denominator by the given denominator and multiply the quotient by the given numerator. Our illustration should make this clear. Notice that the value of each of the fractions remains the same as it was. Multiplication is really quite simple. To multiply fractions, you multiply the numerators and put that product over the product of the denominators. Remember that most problems involving fractions on the SAT will want you to put the answers in their reduced form. If, after multiplying or adding, you get a large, unwieldy fraction, you can simply reduce it down to size. Just find the highest factor that is common to both the numerator and the denominator, and then eliminate them, that is, cancel them out. Cancellation can be used to make operations with fractions easier, to eliminate having to multiply or divide huge numbers.
When dividing fractions, never forget this essential first step. Invert the divisor, that's the second fraction, and then follow the procedure for multiplication.
Remember these devils? Mixed numbers. A whole number and a fraction. Be sure you know how to convert them into what we call improper fractions, that is, fractions with a value of 1 or greater. One way to do so is multiply the integer by the denominator and add the product to the numerator of the fraction. In this manner, it is easy to see that 3 1/2 become 7/2, or 7/2. Fractions? They seem so small, so inconsequential. But please bear in mind that so many of the problems on the SAT require you to be able to handle them with ease, to reduce them as far as they can be reduced, to convert mixed fractions, to know how to compare them. You will be asked to determine which is the larger of two fractions, or to know which is the largest of several. Don't be misled by fractions with seemingly big numbers. Fractions such as this. You must realize that this little fraction, or what appears to be a little fraction, is far greater in value than the one with all the digits. That little sideways b means greater than, in case you forgot. And bear in mind that when you multiply proper fractions, the product is lesser in value than the two factors. Look before you leap to answers that look good at the first glance. And finally, pay attention to these special kinds of fractions, those with denominators of 10 or multiples of 10. Know that you can easily convert them to decimals. Silence! I said decimals, not decibels, demonic dummies. Indeed, decimals are just another way of illustrating fractions. In fact, all fractions can be converted to decimals simply by dividing the denominator into the numerator. When the denominator is 10, or 100, or any multiple of 10, the task is easy. Simply place the decimal point in the proper place in the numerator. 6/10 becomes decimal point 6. 60/100 is exactly the same, and so is 600/1000. But to convert 6/100, you must place a 0 after the decimal point in front of the 6. Note that the decimal point serves a very special purpose. Its placement tells you the value of the number. Let's see what happens to the value when we move the 6 in relationship to the decimal point. The farther to the right the 6 goes, the smaller its value becomes. And why is this infinitesimal little dot so important? Let's try this exercise. Take this number and place a decimal point anywhere you choose. Can't decide? Well, suppose the decimal point determines the amount of money you should be rewarded for demolishing these demons. Or suppose it determines the number of hours you will be required to spend in this daunting dungeon, Where shall you place the decimal point then? As you can see, in the same series of digits, the farther right the decimal point goes, the greater the value. The farther the left, the lower the value. And perhaps more to the decimal point. Your understanding of these fine points will make your tasks on the SAT so much easier. For no doubt, you will encounter a problem which asks you to compare two decimals. When adding and subtracting again, be sure to line up the numbers in the right columns. You laugh. Many points have been stolen by the decimal demons. The way to keep them in their place is simply that. Be sure to keep them in their proper place. When multiplying numbers with decimals, you must keep track of the number of digits to the right of the decimal point. Count them up and place the decimal point that many places to the left of the last number of the product. To divide a decimal into another number, you must banish the decimal point in the divisor. Move the decimal point over so that the divisor is a whole number. And then move the decimal point over the same exact number of spaces in the dividend.
Listen, the demons are growing quieter. Good.
We are about 75% done. Percentages. Just a little matter of hundreds, eh? Remember your root words from the verbal part of the test? Percent, cent, meaning hundreds. Remember? Well, you will now. Percentages, it seems, are often converted into and out of many things, like decimals. Indeed, a percent is another way of expressing a decimal. To convert a decimal to a percentage, simply move the decimal point 2 places to the right and add a percent sign. This conversion procedure can work in reverse. Make a percentage into a decimal by removing the percentage sign and placing a decimal 2 points to the left. Decimals and percentages are easily transformed into fractions, with or without a full moon. It's just a matter of moving the decimal point 2 spaces to the right, or remove the percentage sign and place the numbers over 100. See how 0.60 becomes 60%, which can then become 60 over 100? Do you find 60 over 100 too unwieldy? Notice you can then reduce the fraction to 6 over 10, or even further, to 3 over 5. Converting fractions to percentages is a touch trickier. Don't mind them. They know they are doomed. Let's say 3/4 equals what percent? Again, my friend, it's hundreds. So just place the unknown what over 100. Call the unknown x for easy handling. And surely you know what to do now. 3/4 equals x over 100. That makes 3 over 4 times 100%, which equals 75%. I must hurry. Dawn approaches. But there is one more arithmetic demon for you to silence, perhaps the trickiest of them all. Averages. You know all about averaging, finding the average set of numbers by totaling the numbers and dividing by the number of numbers. The formula for finding an average is average equals the sum total of whatevers over the number of whatevers. Confusing? Let's illustrate by way of an example. What is the average of these 3 numbers? 4, 6, 11. You add up the numbers and divide them by 3, which is how many numbers there are. 21 divided by 3 equals 7. Simple? Yes. But beware these common pitfalls. Many guests to the castle, guests just like you, forget to find the total number of whatevers before adding the numbers up. And many forget to add up all of the numbers. For example, suppose Bob the vampire bit 2 people in one night, 3 people each of the next 2 nights, and 5 people on the 4th night. How many numbers do you have to add up? Silence, demons! Do not listen to them. This answer is incorrect. The total number of nights is 4, not 3.
How, 4 nights?
This is wrong too. It's the total number of bytes divided by the total number of nights. Remember, Bob bit 2 people one night, 3 people one night, 3 people another night, and 5 people another night. That's a total of 13 people, a very telling number, in 4 nights. Now, a few more tricks about averaging. In many averaging problems, you may be presented with only partial information. If you are told, for example, that the average number of demons found in a haunted castle is 75, and that 30% of the haunted castles have an average of 65 demons, what would the average number of demons found in the remaining 70% of the haunted castles be? How many haunted castles are there? You don't know. So you have to pick a number that's easy to work with, say 10. The total number of demons in all of the castles is 10 times 75, or 750. 30% of 10 castles is 3. You know that 3 castles has an average of 65 demons each. So the total number in these castles is 3 times 65, or 195. The remaining 70%, or 7 castles, must have a total number of demons equal to 750 minus 195, which equals 555. The average number of demons in this group of castles is 555 divided by 7, or... Don't panic when you see tricky problems like this. Relax and think of the simple points we provided here today at Castle Integer. There, that wasn't so hard. There's nothing to be afraid of if you remember your basic building blocks and use them carefully. Don't take them for granted. If you are careless with but one small decimal point, you too may become lost in the endless night. Fear not the demons of math. They will only get out if you let them. And now, my friends, we must part. Your way is to the light, and mine. Farewell.
We got everything to lose. SAT blues. We got everything to lose.
Hello, music fans the world over. This is Jimmy J speaking to you from our studio in downtown Springfield. This is the day that you've all been waiting for, our live telecast, Math Aid, the benefit show for all you kids out there preparing for the Scholastic Aptitude Tests. As you know, dozens of the top recording artists in the world of pop music have donated their time and talent to this extraordinary event. Via our satellite feed, we'll be taking you live to locations all over the world to interview artists like
Nigel McGuffin of the Constants, Felix Funk and his Funky Functions, Rib Roots and the Radicals, Casey Cube and the Exponents, that fabulous doo-wop group, Linus and the Equations, and Miss Polynomial, and of course my co-host, the granddaddy of country music, Johnny B. Squared.
But don't go away, because we'll be right back with Math Aid.
I got a taste for one with the juice. I want the orange that turns it loose. We got a thirst for something cool and light. All we need is mandarin orange slice. With 10% juice, we got the juice. It's the #1 twist. We got the taste, #1 fist. We got the juice. Diet too. Slice, slice.
Hi, Jimmy J here, back with Math Aid. This segment of the show will be dedicated to algebra. In case you didn't know it, about 1/3 of the math sections on the SAT involve algebra, so that makes it very important to know how to solve algebraic equations. With me as co-host is someone who obviously knows the formula for musical hits, Mr. Johnny B. Squared. Good to have you here, Johnny B.
Well, Jimmy J, it's great to be here.
Now, we're here to help kids preparing for the SAT, so let's get right down to business. We'll start with the basics. What are the first things the kids should know about the algebra on the SAT?
Well, you know, Jimmy, algebra is a lot like music, whether it be country music, rock, rhythm or blues, what have you. See, if you know some basic chords and tempos and musical patterns, well, you can write and play as many as 100 different tunes. See, in algebra, it's the same way. If you know the basic rules and principles and shortcuts, you can solve just about any algebraic problem that comes up.
So, how can they learn some tricks to help them do that?
Well, first, we want to give the kids some concepts to remember. Now, let's say you have something like this. That's an equation. I'm sure you all know that. Now, if you want to make a sentence out of that equation, you have 2x plus 3y equal 12. Now, in an equation, you have terms instead of words. So in this equation, 2x is a term. So whenever you're talking about math, you got to know what the word term means.
I see. So then 3y is a term. Is 12 a term?
Oh, that's right. 12 is a term. Now, the numbers in front of the letters in each of the terms are called coefficients. So 2 is the coefficient for x, and 3 is the coefficient for y. Now, an expression is a combination of terms and mathematical operations. So 2x plus 3y is what mathematicians call an expression. And if you have an expression with 2 or more terms, that's what we call a polynomial.
And what better way to introduce our very special guest, Johnny B's lovely daughter and one of country music's hottest new singing talents, Miss Polynomial. Come on out, Polly.
Hey, baby.
Hi. 'Cause 2 minus 1 equals 7.
Thank you, baby.
Yes, 2 minus 1 equals 7. Hello, Daddy.
Hey, baby.
Hello, Jimmy J.
Well, hello, Polly. I bet your daddy is just thrilled about your new song, 2 minus 1 equals sad.
Oh, he is, Jimmy J. Of course, without Daddy, I couldn't have done it.
Baby.
I know just what you mean, Polly. I know I couldn't have done this very special benefit without the help of Johnny B. Squared and all our guests. Now, we've got a lot to cover, so let's get back to the task at hand here. Polly's going to help explain how to work with these expressions.
That's right. Now, I'm sure most of our fans know this stuff, but it's important to keep these ideas in mind as we go along. Now, on the SAT, sometimes they'll give you a problem that asks you to evaluate a certain expression, see? Now, by evaluate, they mean just to substitute numbers for the letters and then add, subtract, multiply, or divide to come up with a number.
For example, what is the value of 2D if D equals 3? You just plug in the number 3, multiply, and get 6.
That sounds easy enough.
Well, it is, JJ, but when some kids see something like this...
They get all panicked and don't know what to do.
Well, now there are a lot of ways to approach this problem. Some kids will first try to figure out what x equals. Well, that's simple. If 3x equals 1, then x must equal 1/3.
Now, you try to put that fraction in an equation, and you find out you have to deal with more fractions. And that's where lots of little errors in calculation begin.
The easy way around this is to remember that 3x equals 1. So you start by just substituting 1 for 3x. What do you do with the 9x? It's easy to see that that's just 3 times 3x, or 3 times 1, or just 3. Then you just put in a 1 for the other 3x and do the calculation.
So now you have 3 plus the expression in parentheses, which is 1 minus 4 squared. That becomes 3 plus minus 3 squared. Finally, you have 3 plus 9, which equals 12.
So kids taking the test should remember to look for shortcuts before jumping in to solve the problem in the usual ways.
Well, you two make it sound so easy.
Well, it's not very hard. Just like with music, you gotta practice to make it second nature.
As I was watching Polly solve that last equation, I kept wondering, how do you remember which of those steps to do first? To answer that question, we're going to take you across the Atlantic Ocean to the UK, where my counterpart over there, Jock Wellington Jones, is standing by with Nigel McGuffin of the Constance.
Thanks, Jimmy. Jock Wellington Jones here, and hello to all our good friends in the US of A. A catchy little tune, eh? I have with me the lead singer of the very, very famous group who sings it, Nigel McGuffin of the Constance.
Hello, Jock. Glad to be here.
Good. Well, now you promised you'd answer the musical question that's been on everybody's mind these days, and that is, what in the name of the Queen God bless her, does the song mean?
Well, you see, we've got this drummer Rocco, see? And he's got this crazy aunt. And whenever she comes in, she starts spouting mathematical formulas and equations, you know, things like that. She just kind of blurts them out like.
Quite a cheeky little habit, I should say.
Yeah, it is. You know, in fact, a couple of months ago, we were in the studio, and she come in and starts going on, you know, with x squared plus 2y equals 64. That's when Rocco started apologizing. He went, "Hey, please excuse my dear Aunt Sally." Well, you've got to admit, it was a bit strange her going on like that.
I should say.
Well, naturally, we wrote a song about it. In fact, if you listen really close to the record, you can hear Aunt Sally in the background there.
You mean those high-pitched vocals are actually Aunt Sally singing mathematical equations?
That's exactly right. That little trill sound is really Aunt Sally singing x squared plus 2y equals 64. You know, played through a ring modulator and recorded at double speed. We thought it was quite a nice effect, Dad.
I think he's putting us on. That's a charming story about Rocco's Aunt Sally, but the word is that the line, "Please excuse my dear Aunt Sally," has some hidden significance that would be of tremendous help to all our audience, all those kids studying for the SATs.
Yeah, well, that's right. See, the first letter of each word, "Please excuse my dear Aunt Sally," makes up the initials P, E, M, D, A, S, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now, when you're trying to figure out mathematical equations and expressions, you have to perform the operations in the correct order. Otherwise, you'll get all bunged up. Well, I've worked out a little example for you. Let's say you have a problem like this. If x equals 2, y equals 6, and z equals 8, what is the value of 3x squared plus 4 over 3 times y minus, parentheses, 2z minus 5, close parentheses, eh?
I have no idea.
Well, mate, all you have to do is remember our little song. I've got a video to show the kids how it works.
Well, let's have a look.
And Sally comes walking in the room. And first she says,
Parentheses, parentheses, always start with these. Parentheses, parentheses, it's really quite a breeze.
Whatever does she mean, if you please?
Parentheses, parentheses, always start with these. Parentheses, parentheses, it's really quite a breeze.
I don't understand this.
If you please, excuse my dear Aunt Sally. Please, 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 excuse my dear Aunt Sally. Please excuse her, but never lose her. Oh, please, excuse my dear Aunt Sally.
and then she says,
It takes a few moments to handle those exponents, those little 2s and 3s. It takes a few moments to handle those exponents, those little 2s and 3s.
I don't know what she's talking about.
If you please, excuse my dear Aunt Sally. Please, 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 excuse my dear Aunt Sally. Please excuse her, but don't confuse her, oh please. Excuse my dear Aunt Sally.
oh, now here she comes again.
First multiply and then divide, add and then subtract. It's as easy as the ABCs. Whatever is this that she means? First multiply, then divide, add, then subtract. It's as easy as the ABCs.
What is the shrimp? I ain't
If you please, excuse my dear Aunt Sally. Please, please,
Well, I'm impressed with your algebraic skill, Nigel, and I'm sure it will be of a big help to all your fans in the US of A planning to go to university.
Well, if they remember our song as they're taking the test, it might help them to get a better score.
I'm sure they will. Cheers, and good to see you again, Nigel.
Ta, Governor.
Meanwhile, home viewers, we're going to give you a chance to put the song Please Excuse My Dear Aunt Sally to the test.
If you please.
We're back live from our studio, and I'm talking with Johnny B. Squared. Loved that Please Excuse My Dear Aunt Sally.
That's a real humdinger of a song for this benefit.
So what do we do to add to what we've learned so far?
Well, JJ, every school kid learns a little trick called factoring, and it's one of the most important things to remember for the algebra problems on the SAT. A factor, remember, is one of two or more numbers which, when you multiply them, give you a product. So factoring is where you sort of separate an expression into its factors. Now, if you come across something like this, you know you can change it into this.
Johnny B., I'm great with words, but not with numbers. So maybe you could help me explain how that works.
Okay, Jimmy, sure. Now, the expression x squared plus 2x has the term x on both sides of the plus sign. So we can factor out the x and put what remains in parentheses. And you can also go the other way around. So if you have x times x plus 2, you can multiply through by x to get x squared plus 2x.
Now, what would you call that? Unfactoring?
Well, sure, I guess you could, Jimmy. Whatever helps the kids to remember what they need to know for the test. Now, most kids taking the SAT know how to factor. But the trick is this. On the SAT, when you come across a problem that could be factored, you go ahead and factor it, because more than likely it'll help you get the answer quicker. And here's a good example of the kind of factoring problem found on the SAT. Factor out that y and you get this. But if you come across a problem with expressions that could be unfactored, to use your word, Jimmy, then you go ahead and do so. Once again, that should help you find the answer quicker. So suppose you get this problem, and you get these choices.
Well, I guess you would unfactor.
That's right. And you'd get negative 3a plus 3b. Then you would factor again to get 3 times b minus a.
Well, maybe the kids watching will get the hang of it.
And now, live from a studio somewhere on Main Street, USA, Linus and the Equations. Ready, Linus?
Cut! Cut! Where's Linus? Where's Linus? Linus didn't show. He didn't roll something. Go to a commercial. Anything. What is this? What is this child doing in the set? Who is this kid? What do you want?
Is this where they do that math aid show?
Yes. We're really busy, kid. Can you go play?
I'm Linus. And these are my equations. I'm supposed to do something on equations.
Linus and the Equations are a doo-wop group.
What's a doo-wop group? I don't know anything about doo-wop groups. I'm just a kid, but a very gifted kid. I know all about linear equations and quadratic equations. You want to see my act?
Well, okay. Go for it. Do it.
Okay. Here goes. Well, first you have to know what an equation is, okay? An equation is like a balancing act. All the things on the left side have to equal all the things on the right side. Over here, I have 3 x blocks and 5 y blocks. And on the right side, I have 4 x blocks and 2 y blocks. That's an equation. I can simplify real easy. Watch. I take the 3 x blocks from this side, so I have to take 3 x blocks from the other side. Now I have 5 y blocks on one side, and that's equal to 1 x block and 2 y blocks on the other side. You can simplify this again. I take 2 y blocks from the left side and 2 y blocks from the right side, and that leaves 3 y blocks equals 1 x block.
wonderful kid. What a beautiful kid.
Wait!
Yes.
Wait. That's just the baby stuff. I haven't finished. I have a little play to show you how to solve linear equations. It's called How to Find X, the Unknown. Linus presents X, the Unknown, starring X for Math Aid. Now this looks like a bunch of blocks, but it's really a linear equation. J equals xk over m plus x. We've got to find x, the unknown. How do we do it? Easy, as long as you follow the rules for solving linear equations. Rule number 1. If there are fractions or decimals in the equation, remove them by the use of multiplication. Well, we don't have any decimals, but we do have a fraction. So, we get rid of it by multiplying both sides by the expression m plus x. And now we have this. Look. See, we also moved one of the x's over to the other side. And we had to put the expression m plus x in parentheses. Rule number 2. Expand any expressions enclosed in parentheses. Now we multiply j times the expression in the parentheses. So we get jm plus jx equals xk. Rule number 3. Collect all terms containing the unknown on one side of the equation. See? We have an x block on the left and one on the right. So, we subtract the term jx from both sides. We take it away from here and move it over to the right. And don't forget to add the negative sign. Rule number 4. When terms cannot be combined, find the coefficient by factoring. See, here's how we find x. We factor out the x from the expression xk minus jx. So we have jm equals x times k minus j. Now we're ready for the last step. Rule number 5. Once you've found the coefficient, divide both sides by the coefficient. So, we divide the left side by k minus j, and the right side by k minus j. And here's what we get. Hey, we found x, the unknown. Jm over k minus j equals x. Simple!
That was beautiful. What a kid. What a kid.
Oh, hey, yo. Gee, I'm here, finally. I got caught in traffic. Sorry I'm late. And you know, I have no idea what those equations are.
Well, Linus, it looks like you've been replaced.
What? Who's this kid?
Well, he says his name is Linus, and he does a bit about equations. He just did something on linear equations, which is very cute.
Right. Yeah, well, I'm here to take over now, and I got something to say about quadratic equations.
I know all about those.
You ready? All right, you know, I'm going to tell you a few things about quadratic expressions and equations. You know, quadratic equations may look scary, but they don't have to be. To prepare for the SATs, there are just a few things you have to know about quadratic expressions and equations. Like, whenever you see something like this, x squared minus y squared, just remember, that's a quadratic expression that can be factored into this, x plus y times x minus y. And here's another quadratic equation you're often going to see on the SATs. X squared plus 2xy plus y squared. This expression can be factored like so. X squared plus 2xy plus y squared equals x plus y times x plus y, which equals x plus y squared. So, what's the big deal with these quadratic expressions and equations? Well, I don't even really know why they have them. But I do know that...
I know what they're for.
Yo, kid, you had your turn, okay? Like I was saying, I do know that they come in handy on the SAT tests. Like, for instance, here's one of the problems they had on an SAT. If x plus 3 squared equals x minus 3 squared, then x equals what? A, 0, B, 1, C, 3, D, 6, or E, 9. You could start putting all the different answers in and come up with the right answer that way, but if you remember quadratic equations, you could unfactor both sides of the equation kind of like this. X plus 3 times x plus 3, which equals x squared plus 6x plus 9, and x plus 3 times x minus 3, which equals x squared minus 6x plus 9. Now you have this. X squared plus 6x plus 9 equals x squared minus 6x plus 9. Now it's easy. Just take out the terms that are the same on both sides of the equation, and you're left with this. 6x equals negative 6x, or x equals negative x, or x equals 0. See? So the answer is A, 0. Okay, you didn't think that was such a big deal, huh? Well, then look at this one. Here's another problem you're going to find in the SATs. 45 squared plus 2 times 45 times 55 plus 55 squared equals what? A, 5,050, B, 9,100, C, 9,900, D, 10,000, or E, 14,950. Hey, who wants to do all that multiplying, huh? Not me, no way. You don't have to either, as long as you remember this stuff about quadratic equations. Remember before when I showed you this quadratic expression, x squared plus 2xy plus y squared? Does that look familiar or what? Of course. Look, see, this problem is the same thing as this expression, so all you gotta do is what? That's right, factor. And you get this. 45 plus 55 times 45 plus 55, which equals 100 times 100, or 10,000. Piece of cake, right? Of course. The answer is D, and that is the truth. Hey, let me see that thing. You gotta keep this thing in tune, you know. You're gonna be a performer.
That was great. Mwah! Back to you, Jimmy. Run!
That's SAT Blues. And I hope our rock special can help you cure your SAT blues. Johnny B, I want to show the viewers something that I'm sure everyone will recognize. That distinctive signature of yours. It reminds me of one of the things in math that always trips me up. Exponents.
Exponents. That's right, Jimmy. You gotta know how to work with these. In fact, I just did an album with Casey Cube and the exponents, and it just went gold. We called it B squared plus C cubed equals power.
That's another winner, Johnny B. Let's see if we can talk to Casey now, standing by in a studio on the West Coast. Casey?
Hey, I hear you, Jimmy. I've been watching the show. It's great.
Now, what can you tell the kids out there about exponents?
Exponents are like shorthand. You take b squared, for instance. Most kids know that that means b to the second power, or b times b. So, if b were 2, it would be 2 times 2, or 4. Now, c cubed is c to the third power, or c times c times c. If c were 3, that would be 3 cubed, or 3 times 3 times 3, which equals 27. That's the easy part. Now, here's the tricky part. What do you do with this? b squared times b cubed equals what? Well, if you write it out, you see how it works. b times b times b times b times b equals what? So you can see that another way to write this is b to the 5th, or b to the 5th power. So if you see a similar problem on the SAT, you could apply this rule. When multiplying base numbers with exponents, you just add the exponents. In this case, 2 plus 3 equals 5. So it's b to the 5th. Now let's substitute a 2 for the b. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which equals 32.
Well, like, what if you have b squared plus b cubed?
Addition.
Good question, Conrad. So let's try it. By substituting the number 2 for b. 2 squared equals 4, and 2 cubed equals 8. 8 plus 4 equals 12. But if you add the exponents, you get 2 to the 5th power, which we just saw was 32. Quite a difference, huh? So be very careful when you're doing these kinds of problems. Be sure to check if it's multiplication or addition. Only when it's multiplication do you add the exponents of the same base. Division is the reverse of multiplication. So, what do you think the rule is for dividing exponents with the same base?
You subtract the smaller exponent from the larger one.
That's right. Like b to the 5th divided by b squared would equal b cubed, which might also be shown like this. B to the 5th over b squared equals b cubed. To check it out, plug in a number. We'll use 2 again. 2 to the 5th over 2 squared equals 2 cubed, which equals 8. Or, another way to look at it, 2 times 2 times 2 times 2 times 2 over 2 times 2 equals 32 over 4, which also equals 8. Now don't forget, don't try to use the rule for division for an expression that involves subtraction. B to the 5th power minus b squared equals what? Substituting a 2 for b. 2 to the 5th power minus 2 squared equals 32 minus 4, which equals 28. Don't subtract the exponents. Now here's a tip for you as you're doing problems on the SAT. If you can't remember the rule for something, try substituting small numbers for the letters and see what you get. But when working with exponents, you have to remember a few other tricky points. When the exponent is even, as in b squared, the variable b will always have 2 values.
Ooh, now, how's that again?
Well, if you recall, Conrad, the rules for working with signed numbers, you know that multiplying 2 numbers with the same sign, both positive or both negative, you always get a positive product. So, for b squared, b could be either a positive or a negative number. As in 2 squared equals 4, or negative 2 squared equals 4. So, in a problem in which the result is b squared, b would equal positive or negative b. But this is not true for odd-numbered exponents. b equals 2 if b cubed equals 8, and b equals negative 2 if b cubed equals negative 8. Now here's some other tricks with exponents. So if you have a base number that is greater than 1, it always gives you a larger product. That's positive 2 squared equals 4. But if you have a fraction, the result will be a number smaller than the one squared or cubed. Be sure to use this information to help you eliminate answer choices on the SAT math sections. For example, if the problem is a quantitative comparison like this, which is greater, A or B, you know that a fraction with an exponent gives you a smaller value than the fraction itself. So, in this example, you can easily eliminate answers A and C. Well, Jimmy, that should give the kids a few pointers to help them earn some points on the SAT.
Thanks, Casey. And we're about to take you to Chicago to hear from Rip Roots and his Radicals. Not many fans know that Rip and all the members of the band have high math aptitudes. And between sessions, they like to hang out and argue the fine points of math. No, really. So we're going to eavesdrop on them as they debate what you need to know about, well, the obvious, roots and radicals. First, let's say hello to Rip. Rip?
Yeah? Oh, I hear you, Jimmy. Hey! All right. Hey, this Math 8 thing isn't exactly like Woodstock, but I can dig it, you know? I mean, these kids today, they really want to go to college. All right. That's it.
Glad you joined us for Math Aid, Rip. So with no further ado, we'll just sit back and let you guys do your thing.
All right, okay, now here goes. Now, whenever you see this radical sign, like this right here, you know they want you to find the square root of the number that's under the sign.
Yeah.
Like, square root like, a square root of 25 is 5. It's like the opposite of 5 squared. Peace, man.
Yeah.
You with me so far, Radical?
Yeah, man, far out.
Okay, now for the SAT, there's just a few things that you gotta know about radicals, all right? First, you can only add and subtract radicals if they are exactly the same.
That's right.
Now, let's say that you have this, okay?
Oh, yeah, man.
Oh, man, that's easy, man. You add 3 plus 4 to get 7 radical 2.
Oh, groovy.
Okay, or if the problem was this, hey, the answer would just be the radical of 2.
Oh, that's easy, man.
Come on, give us something harder, man.
Yeah.
Okay, all right, guys, all right. Then what do you do with this? Oh, sorry. Okay.
Oh, yeah.
Oh, yeah. See, now that can't be done, man. You can't add radicals that are different.
Of course you can. You just have to figure out the square roots and then add.
Oh. Yeah, well, that would take a lot of time. And besides, they don't ask you things like that on the SAT.
Whoa, man. What if they ask if 4 radical 2 is more or less than something like, say, radical 7?
Lighten 'em up, guys. Okay. It's true, you're not expected to do a lot of time-consuming figuring, but it helps to have a sense of the radicals that aren't perfect square roots.
Right on, you're right.
So that you can make educated guesses.
Yeah.
Now, here's something that I used on the SATs myself. It's a long time ago, but it still works today.
Yeah.
Now, you know that the square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3. So you make this little number line like this.
Far out.
Right, man. That's all right.
Now, you can figure the square root of 2 and the square root of 3 are between numbers 1 and 2. And the square roots of 5, 6, 7, and 8 are between the numbers 2 and 3, and so on. I don't want to write on the piano. Okay. Now, with this, you can make calculated guesses without having to do the long calculations.
Yeah, all right, okay, that's cool. So, now, you can see that the square root of 2 is maybe not quite 1.5.
Right.
And the square root of 7 is probably a little over 2.6.
Okay, dude.
So, 4 times radical 2 is definitely greater than radical 7.
Right on. Yeah, far out. Okay.
Can I go on now?
Oh, yeah,
man.
yeah, sure. Yeah.
Go ahead.
All right, there's another way to deal with adding radicals that aren't the same. Now, say you have this.
Uh-huh.
Now what do you do?
You can't use your little number line idea because these numbers are too high.
Yeah, so you like have to factor out any perfect squares.
Yeah, definitely, man. Gotta get rid of the square.
Right on. Right. So what you do is you divide both numbers by